In the previous videos, I talked about the high level architecture of sketch to design video, and we also talked about the data flow of this application. So if you haven't watched those videos, I would highly recommend you to check them out, as it will give you a better idea on the context of the today's video. So today we will be designing the schema, the database schema for our sketch to design application. So I have already created that schema using this draw SQL application, where I can just write the fields in this input box and it will create that table for us. I have created the schema on this website so I can show you it visually in a better way. So first of all, I will divide this schema into 4 parts so that we can separate each of the functionality and which database schema is used for which functionality. Let me group these. This will be our user and billings. Let me just change the color. Then we have canvas here. Let's give it orange color. Now let's group these, name them project system. Yeah. Oh, let me rename this as well. Canvas. The last group, AI generation system. Cool. Now we have our schema dividing in 4 functionalities. Let's visit them one by one. So first of all, we have user and billing functionality. For that, we have the user table. We will store the basic information, name, email, image, this image for the profile that the user will add as an avatar image, which is connected to these tables. Now this is interesting. You see, we have one subscription. You might have already gotten the idea for this. It is the payment that the user made to subscribe to our application, and this is flexible. We would change it according to the requirement and the data that Stripe provides us if we are using Stripe. So let me just go through it. User, we have user ID, which is connected to user. Stripe customer ID, Stripe subscription ID, status. Yeah. So what will the status will be? It will be active, cancelled, past, trialing. So the use this it is the status for the subscription. The subscription could be active, or the user might have cancelled that subscription. The user might have pending payment, or user could have been trialing. The same, we have the plan type. It would be basic, pro, enterprise. If we want to give more tokens to the user, it's used for that purpose. Then current, when will the subscription end? When will the subscription end? Whether the if the user has cancelled the subscription, when will the trial end? And created and updated at field, which will be presented almost every of the tables. Now we have one credit ledger and a credit balance. So credit balance will be our, you could say, quick read data that we can read to check the current balance for the user, how many credit it have, and we are only storing the balance here, and it is linked to the user tables. Now this is the most important table in our billing system. It's credit ledger. Now if you have heard the word ledger, you would understand it. Ledger is nothing but a record of all the transaction. We will be storing all the transaction done by the users in this credit ledger. It will be our single source of truth for all the transactions and tokens. Uh, it would connect it to the user, which subscription caused this ledger to be created. And you notice that it's an optional field. Why it's an optional field, I will tell you that later. The amount that the credit, the amount number of amount the credit has been consumed or granted. Now the type, it can be grant, consume, or adjust. You could understand that grant is when the user gets the token from the subscription, and consume is when the user creates and design, and adjust is used for some special cases like the generation failed. Now if the generation has failed, we don't want to charge the user, right? We would revert those tokens back to the user. For that we use the type adjust. Then the reason, this is the metadata that we can provide, whether it was credited due to subscription or was it added due to a failed design creation. Now, here we have an important field, idempotency key, which has a unique constant. If you can see, it's a unique constant. Why are we storing an idempotency key here? And what is even an idempotency key? Idempotency key is nothing but a hash string that we receive when our API or when a service or a function is called, and it is used to validate whether this request is a duplicate one or not. Let's suppose uh, the user made a payment. Our server received that message that hey, the user has successfully received the payment. Now grant the credit to the user. We granted, let's say, 100 tokens to the user. Now, due to some network issue or some client side problems, the browser sent that request again. The user has only made the payment once. And if we process that request again, we would be granting the token to the user again. We do not want that. We should only provide 100 tokens to the user, not 200 due to the second request. That is why we send an idempotency key in the request so that we can identify whether this request is unique or a duplicate one. And if it's a duplicate, we will just ignore it. So now we have covered the user set billing schema. We have three more schemas here. One is for Canvas, the project system, and AI generation. Let's talk about project system. So we have our project here. This is the main project where the user will draw the sketches and all of its corresponding data will be stored. We would have the name, description, viewport data. What is this viewport data? We will be storing the scroll level of the user, the position where the user is looking in the canvas. So let's say the user is currently focused on this element and the user closed the tab and again open the tab or refresh the tab. We want to show this part to the user directly. The user shouldn't be like whenever the page refresh, we open it completely zoomed out and user have to go scroll it again and go here. That's why we store the viewport data here, where the current user is looking at, what is the zoom level. It's and then we have the thumbnail for the project, which we will generate when the design is generated. Then is public, whether the user wanted this project to be public or private. And then similarly, we have created and updated that. The project have two more objects here, or rather two more data tables. One is style guide, the one that we talked about here. Again, if you haven't watched those previous video, it won't make much sense to you. So I would suggest that you watch them first and then come back. So this is the style guide that we would have, the colors, the typography for the image design that the user want to create. We would have theme name, theme description. This will all be generated using the AI. Same with the color, typography, spacing. These are the JSON object. Now we will also be storing a raw output, the output that the AI give us directly. In these in this theme name description, we will store the values of these objects directly, but in this raw output, we will store the output as it is. The other data table that we have is project image. And if you notice, we have a URL and type here. URL for the image. And what is this type? If I hover over here, you will see it has it is an enum with mood board and inspiration. In the architecture, we discuss how we have an inspiration image and a mood board image. It is similar to that. This is the same image. Now, there is one question. Why are we creating a table for the project image separately? Why not just have an image object here and call it a day? Why store it in a separate image? Let's address these one by one. If we store an image here directly, which we could call an array of string. Now, if we store those URL directly in this image object, how will we know whether it's an mood board image or an inspiration image? We would further have to change this text data type to an JSON object where we will set the type to be mood board or inspiration. Now, to solve this, we could just have two separate images, mood board and an inspiration image. That's fine as well, right? We could do that. Now we have separated the mood board image and the inspiration image. Then why did we created this table separately again? So suppose the user have uploaded multiple inspiration image here. See, uh, let's do it here. The user have uploaded one mood board image, second mood board image. Let's say the user wants to remove the first image. He only wants the second image to be used to extract these values. How we will identify which image do we have to delete from here? This is an array, right? Array of string. We will be storing the URL here. But how we will know which image we have to delete? We can't, right? Because we are only storing the URL here. We could probably use it based on the index, but it could be wrong. It could delete the wrong image. That is why we are not storing it directly in the table and instead creating a new table data where we can separate it based on mood board and inspiration, and we also have an ID for that image. So if the user wants to remove the first image, we would just have the ID of that image. So we can delete it directly, right? So this is the reason that we created this project image. The second part is also done. Let's move to the third part, the canvas. The canvas is connected to the project, right? The what It's contain the data which the user will store. First part, we have the frame. Uh, think of it as a sheet on which the user will draw. We will have the name of the frame. We could probably remove this. We might not need a name for a frame, but we could decide that later. The height of the frame, width, x position, y position. What are these x and y position? These are the coordinates where this frame is located. If we consider this, if we consider this as a canvas, we, if we consider this as a whole canvas, uh, let's say 0, comma 0. The frame, when is the frame starting? This coordinate, maybe 12, comma 10. So using this x and y value, we could position that frame where it is present. This is why we are storing this position. And here I have stored them directly in height, width, x and y, but we should probably create a position with an enum data type, which will have not enum, but an JSON data type with x and y position. Same with height and width. We could probably have a viewport field which will store this height and width. Now moving to the next schema, we have shape. Uh, the user can draw this shape inside a frame and it will be linked to the frame. Similar, it is very similar to frame. It will be height, width, its x and y coordinates. We also have a type here. If we go inside it, what are type saying? Arrow, line, rectangle, circle, text. These are the tools that we are providing to the user. And if it's a text, what should be written inside the text, that will go here. And these are some styling that the user can customize. Suppose the text should be in red color, or what is the font size that the user want. These kind of thing will be stored in the inside the style. We have covered this third part for the canvas as well. Let's move to the final part, which is related to AI generation of the design. Sorry, generation job. Now we have a generated result table and a generation job. When the user click on the generate button, we would create a generation job which will contain the status, whether it's pending, running, completed, or whether this generation has been failed. An error field to store the error if it occurred. The style guide, which style guide was used, it is linked to it directly, and an input snapshot. Now here comes a question: why are we having an input snapshot when the this table is linked to project? We could directly get this frame and shape, the styles, everything we could just get using the relationship. So why are we having this input snapshot? The reason behind it is that suppose the user created and design, the user click on the generate, the generation job is created, it succeeded or maybe failed. The user modified the design and again click on the generate button, another job will be created. But from our side, we have to figure out why the generation failed. We need to see the data that the user sent to replicate it on our side. This is why we have this input snapshot where we could correctly see what style guide was used, what prompt was used, what were the images, what was the frame data at that time. Now you notice one field is linked to the real-time database style. But in the input snapshot, we are storing the style guide that was used at the time of generation. And when the generation is completed, we would have store it in generated result, which we could, which will be linked to the project, and the user can see all those generated results. Let's go through its field one by one. HTML output, the main output that the AI has generated for the design. Versioning. We are using this versioning here because the user could work on the same design again and again. He could have told to modify text, shift the layout. So we are storing it in version so we could keep track how much the user has modified. The status, pending, running, completed, failed, same as generation job. The job ID, which is connected to generation job, created and updated. And so this is how our database schema. Now we have covered this whole database schema that we have designed for our application, and you might have a pretty good idea of about how this whole application is going to be made. This is how I have designed my database schema, and yeah, it can use a lot of improvement. There might have been mistake that I might have made, and we have now completely discussed this whole database schema. There are definitely things that can be changed or improved in this schema, but this is should be good enough starting point for our application. In the next video, I will probably go deep in the API part, how we will be building the backend API, what will be the routes in our backend, and how everything will connect together. If you found this video helpful, please like this video and subscribe to the channel for such videos. That's it for this video.